All right, in this video, we are looking at solving 1- and 2-step equations. So things to keep in mind when we're solving our equation is our goal is to isolate the variable, or get the variable all alone on its own side. We also have to keep in mind that operations that are the inverses or opposite of each other. So remember, the opposite of addition and is subtraction. And the opposite of subtraction is addition. So those are opposites. And the opposite of multiplication is division. And division is the opposite of multiplication. So we have to know those inverse operations are the opposites. Addition and subtraction are opposite. Multiplication and division are opposite. Sometimes you might see a fraction, and so this should actually be x over 3. There should be a dash in there. A fraction just means division. So this means x divided by 3. If no operation symbol is written between two symbols, it's multiplication. So if you see something like 2x, that means 2 times x. Or if you 5x is 5 times x. And then we always want to do the same thing to both sides. We have to be fair. Always do the same thing to both sides. So let's get into solving an equation. So here I have my variable. I want to get that all by itself. I want to isolate it. When we talk about both sides of the equation, we mean both sides of the equal sign. What I might do sometimes is draw a line through that equal sign, and that divides it. And we have to be fair. So I'm going to put this think of it like a teeter-totter. If I do something to one side of my equation, then I have to do the same thing, otherwise it wouldn't be balanced. So if I took something away from this side, it's going to go up, and this side would fall down. So we have to make sure that we do the same thing. If I take something from both sides, then it's going to stay balanced. Or if I multiply something by both sides, it's going to stay balanced. I want b all by itself. So that means I don't want this plus 3 or this minus 3 here. So I have to think, what can I do to get that to 0? So minus 3, it's a minus 3 here, so I'm going to add 3. Because a minus 3 plus 3 is 0. It goes away. But like I said, if I added 3 items to this side, my teeter-totter would go up. So that means I'd have to add 3 things to the other side to keep it there. Then I draw a line underneath it. These go away. That's 0. It leaves us just with b. Negative 7 plus 3 is going to be a negative 4. And that is our solution. We can also have one like this. Now remember, we said a fraction is division. So this is x divided by 4 equals 3. The opposite of division is multiplication. I want to multiply this side by 4. But if I multiply this side by 4, I have to multiply the other side by 4. The reason that this works is 4 is really 4 over 1, and those end up canceling out, that 4 on the top and the 4 on the bottom. So then all we're left with is x. 3 times 4 is 12. One more example. Draw that line down the middle. Tells us our two sides. I have 2x equals 6. Remember, our the 2 and the x right next to each other means to multiply. So the opposite of multiplying is division. So we're going to divide, and I usually write it like a fraction. A 2 on the top, a 2 on the bottom, those go away. We're just left with x. 6 divided by 2 is 3. So our solution is 3. These are all one-step equations. We only had to do one thing to both sides. We had to either add, multiply, divide, or we could get one where we could subtract as well. But just one thing that we have to do. Now let's look at a two-step equation. Now a two-step equation, there's two things that we have to do. But it's just a repeat of what we already did. So we want to get the variables on one side and the constants on the other side. Or remember, we said the constants were the numbers that didn't change. It's like our whole numbers. After step 1 done, you almost always are going to have just a one-step equation. So it's just kind of repeating what we did. Now, as we work on these, I want you to kind of think of the reverse order of operations. We're going to kind of be working backwards on how we move things or how we undo, because we're really undoing a lot of stuff. And so when we undo something, we have to start backwards on our order of operations. So that means the first thing that we're going to want to undo is any addition or subtraction. So as I look at this, 2x plus 3 equals 15. I have my variable on this side, so I'm going to keep it over here. And I see this addition, so I want to undo that first because we're using that reverse order of operations. To undo the plus 3, remember this is addition, so we're going to use subtraction. We're going to subtract 3. And if I subtract 3 from this side, I'm going to then subtract 3 from the other side. Those cancel out. We're left with 2x equals 15 minus 3, which is 12. Now I have 2x equals 12. This is a one-step equation now. We just do what we did previously. So 2 times x we want to undo, and so we divide both sides by 2. We always use the number that's connected to the variable because that's what we want to get rid of. That goes away. We're left with just x. 12 divided by 2 is 6. Our solution is 6. Now we can check our answer as well, and we probably should do that. The way that we do that is we plug x back in. So 2 instead of x is 6 plus 3. 2 times 6 is 12 plus 3 is 15. And so that works because we're told that we want it to equal 15. Let's look at another example. First, I'm going to draw that line through to separate my equation. I look at my variables on this side, so I want to move things from this side. I have a plus 5, so I want to get rid of that. We're going to subtract 5 from both sides. Those cancel out. I'm left with 1/2 a equals 18 minus 5. Which is 13. Now this, I have 1/2 times a. So we would then divide by 1/2. Or dividing by a fraction is the same thing as multiplying by the reciprocal. Or multiplying by 2 over 1. We could think of it like that. Multiply by 2 and then over 1. These then cancel out. Those cancel out. All we're left with is the a on that side. And that's equal to 13 times 2, which is 26. All right, that concludes these notes. We'll continue working on solving 1- and 2-step equations.